Okay, let's look at this question on the gas laws from November 2018. It's question 5 from November 2018. Here are my formulas for the gas laws. Here are my constants that we need to know. So let's have a look here. A balloon is filled with 160 grams of argon gas. The pressure of the gas is 120 kilopascals at a temperature of 15 degrees. Calculate the volume of the balloon. Okay, we should be able to calculate the volume of the balloon using PV equals nRT. We have a P. We can convert this to a T in Kelvin. We want to find V. Okay, we know R, so the only thing we're missing is N. How will we find N, the number of moles of gas? It's quite easy. They told us the mass of the argon. So if we know the relative molecular mass, we can use N equals M over M to find the number of moles. So the relative molecular mass of argon from your periodic table is 40. And then we're going to use N, the N of argon is equal to M over M. Remember, I can't put fractions here, so I'm busy with the division sign. So the number of moles of argon is going to be, how many grams was it? 160 grams divided by 40, because that was the relative molecular mass. So this is going to give me 4 moles. So N of argon is 4 moles. So now before we start PV equals nRT, let's just calculate here what is the T in Kelvin. So remember, to find the T in Kelvin, it's the temperature in degrees C, which they gave us as 15, plus 273. Look here, standard temperature 273. So this is going to give you 288 Kelvin, because remember, we can't use PV equals nRT unless we are in Kelvin. So let's write the formula, PV equals nRT. My pressure is written here in kilopascals, so I'm going to convert this to pascals. And you can either write times 10 to the power of 3, or you can write 120,000 like that. I prefer to write 120,000 like that because it's easier than putting the exponent in here. The N is 4. We just calculated that. The R is 8,31. And then we want to multiply by the T in Kelvin, which is 288. So if you do some calculation on your calculator, and you are cunning with your calculator, you'll end up with something that looks like that. So the volume, if we round this off, is going to be 0,080, and my unit here is cubic meters, because PV equals nRT ends you up with an answer in cubic meters. Okay, so the second part of the question then, it says to you, the temperature of the gas is now increased by 20 degrees. So there's a difference between increased to 20 degrees and increased by 20 degrees. When it says increased by 20 degrees, we are adding 20 degrees onto the 15. So it'll be 35 degrees C and 288 plus 20 Kelvin. And then it says the initial pressure is doubled. Calculate the new volume of the balloon. Okay, now that you've got this V here, you can use P1 V1 over T1 equals P2 V2 over T2. That's your one option. Or your other option is to just use PV equals nRT again. And I'm going to use PV equals nRT again because it's much easier on the computer screen. So I take my initial temperature, I multiply it by 2 because that's what doubling means. Okay, and this is going to be the number of moles can't change because it's fixed. It's the mass of gas you put in there. The molar gas constant is 8,31, and this is now going to be 288 plus 20, which is going to be 308. Okay, so if you do this all in your calculator, let's check in your calculator. 4 times 8.31 times 308 divided by 240,000. You end up with 0,0426, which we're going to round off to 0,043 cubic meters, because that is the unit we're using here. And that should be your final answer. And we are done with this question.